So what we've got here is another robot kit. I'm hoping this is the one that's got everything in with all the instructions, and this is an Alphabot basic robot building kit for Arduino from Seed Studio, Seed with 3 E's. Okay, so let's have a look what's in the box. Okay, so a couple of wheels, brilliant. We've got an Arduino, so that's an Arduino. I've never seen one of these before. It's an Arduino Plus. So it looks like an Uno Plus. So it's a surface mount version of the Arduino. We have the chassis of the robot with a battery pack underneath. Okay, and it looks like the Arduino Uno will fit in that. We have a bag with, looks like sensors. So we've got ultrasonic sensors. Okay, we've got some mechanical bits, so we've got some mechanical spacers, and it looks like a RC servo motor. So we'll see what that does. A couple of motors, DC motors, the USB cable for programming it, and a chassis. So this looks like it's the top of the chassis board. So what we're going to do is take all of this out of the bags and then talk about each of these components in turn. And let's see how it goes. Okay, so we've taken all the wrappers off the components, and there's more wrapping than going on a Tesco shop. So we've got rid of all of that. So I'll just talk to you about what these components are. So of course the best bit is we've got some motors. A couple of motors there. They will connect to those wheels in a little while. We've got the main base of the robot. Here we have a carrier. It says ultrasonic, so what these are ultrasonic sensors for measuring distance, and I presume that these are going to slot into here shortly. We've also got for some infrared transmitter and receivers, so we'll see what these are used for shortly. We have a little transmitter as well, so it looks like we can have this thing remote controlled. We've got some sensors which look like transmitters and receivers, and these can be used for line following, I think. So these will probably face downwards and look for a black line and tell the robot which way to go. Now these bits, these are an LED and a receiver on the other side. And what they do is they will connect to this motor like that. So this bit on the back is a wheel with holes in it, and it's an encoder wheel. So as the motor rotates, this wheel will turn around as well, and it will turn and interrupt a light beam in between the transmitter and the receiver. And then that interrupted light beam will be a pulse which goes into the microcontroller, so it knows how far the motor's moved and also what speed the motor's moving at. So it can be used for feedback. Okay, just going back to the other bits, we've got the USB cable, which is going to connect to the microcontroller. So we have an Uno Plus microcontroller here. There'll be a USB port on it at the end there. And the microcontroller has got a variety of inputs and outputs, and this will connect to the robot base here. And it's very likely that it will connect upside down, and it should match up with these pins like so. So they should all match up and then push down. But we'll do that after I've built the mechanics of the base. There's also a top part to the robot. Now this is acrylic, and it's covered with this paper, this sticky card. So this can be pulled off. It's quite hard to get a purchase on it, but with a sharp knife you can usually pull that off, and then once it comes off it's quite easy to pull off all in one go. We've got a servo motor, an RC servo motor, a load of different connectors and a caster, and some different spacers and nuts and bolts as well, which will be used to build all of this. Now, it didn't come with any instructions, so I'm going to look online and to see if there are any building instructions, and then I'll put that onto the website. Okay, so we're going to connect these motors onto this robot base. So I've worked out the way round it goes is with the battery pack just downwards for now. So the motors go over where this shadow is like that. We need to keep the motors in position. Okay, so to do that we're going to use these little blue tags, and what they're going to do is go each side of the motor. So if I just feed that through, you can see that we've got one there, that's just dropped out, and I've got another blue tag here. Now they might not look blue, so they'll be covered with this this kind of tape, and the way to do it is just to, you can scratch it with the scissors, get purchase on it, and then pull it off, and then you've got the tag looking fairly new like that. But they can be a bit of a pain to take these bits off, so I'll just do this side as well. Like so. Okay, so we've got these tags and they're going to go on both sides of the motor. Okay, so what we're going to do is these tags are going to be connected through these holes in the motor. So what I'm going to do is put the motor on, and they're going to be connected by these long screws. So in this set there's some long screws here. So it's basically put the long screw through the tag like so, and then put it through the hole in the motor so it comes out the other side, and then connect it onto the other side of the tag like that. And then I'm going to put a nut on that side and then tighten it all up. Oops. Might take me a few attempts to do this, so I won't let you watch because it can be quite painful getting these into the right position. Oops. Okay, but I will show you how the other screw goes in. So we've got another screw, and that will go in through that tag and then through the other side, and then tightening that up, and that will hold the motors. Once the motors are in position, we can start to build it up and then put the wheels on. Always the exciting bit. So we've tightened the screw and the nut on the other side on both of these motors. Wasn't too bad at the end of the day. Being careful that the encoders are still lined up with a gap here. Now we've got the motor wires, and they will go into these sockets here. So just be careful that you're not bending the wire around this motor. If it does come off, it will need to be resoldered or connected somehow. So I'm going to put that straight away in there, and this one in here, so it's not wiggling around anywhere like that. So we've got the two motors connected, and then you can put the wheels on. Why not? Noting that the shaft of the motor has got flat bits on, the wheels have got matching flat bits as well, so just match those up with the wheels, and what you can do is just push on the opposite side of the axle, not on the encoder, and then you can put the wheels on. Just match those two up in that way. Okay, now the robot is going to run in this direction. This is going to be the top of the robot because the batteries are going in here, and we've got our switches in here as well. So we need a base of the robot. That's going to be connected like so, and that'll also protect the wires of the motor. That base will have a caster on. I presume that it's going to be connected like that, and this base will be held on by using these spacers. So I'm going to use these copper spacers with a screw on each side, and then on that screw on the matching side as well. So I'll put those all around and we'll see how we go. Alright, so what we're going to do is going to put the lower part of the base onto the robot. I've just connected the little caster bit, so that will run along like that. So we're going to put this onto here. But before we do that, we have to do a few things. First of all, I've put these spacers all around. So these are those copper, I chose the longer spacers, and this is going to fit on there. And I put this on before I put the copper spacers on because I wanted to know which holes to use for the copper spacers. Now, before we put that all together, there's a few things, because we won't be able to easily access this side of the robot, so we need to put some things nicely out of the way. So I'm going to put the Arduino Uno on, and first thing I'm going to do is to match up these. So just seeing which way round it goes, it looks like the yellow side goes along the towards the front of the robot. So I'm just going to match up the yellow side socket, and once that's matched up, then the rest should all fall into place. So they're matched up, and then you can see that the other side, the blue and the red ones, I'm just going to match them up so they should be lined up, just very carefully making sure that they're all lined up. And once they are, pushing it down so that the Arduino is on the board like that. So that's lined up. There's nothing escaping. There's no wires escaping, and it's really just pushing it all the way down so it doesn't come loose again. Okay, so that's our microcontroller. We still have access to the pins because on the other side of this they all come out here as well, so that's fine. Obviously the wires to the motor were tucked nicely out the way. Now another thing that needs connecting is the sensors for the encoder. So I've got an encoder sensor here. So one's a transmitter, one's a receiver, and it goes the opposite sides of this encoder wheel. So to do that, I found it very tight, but it comes in from the top. So I just straighten the encoder wheel, so when you look at it from the other side, it's bang on in the center of that slot. And then it's a case of carefully getting the encoder, and it just fits into this slot. It's a very, very tight fit, so it might take a few attempts, like so. It's very tight fit, and it should have some screws holding it into place. I should have done that before I attached the motors actually, so I can't do it. I can't quite get to it now. But what you'll see is that the encoder is at both sides of the wheel. And the other thing we need to do is make sure that the cables are attached to the encoder. So because these will be quite hard to get to. So the encoder cables are these 3-pin cables here. And what I can do is attach that. So that's a 3-pin one. So I can just, now the way to get these cables is to bend the cable slightly, and then you can push it through with your finger, and then I can feed that through like that, and then on the other side that will connect into the encoder like so. Okay, just hold it straight. Oops, I'll cut that out. Just hold it straight because it is sagging like at an angle. And is your finger in the way there? No? Okay. Okay, and then the ultrasonic sensor is connected here. I know that because it says trigger and echo. So I've got to put the ultrasonic sensor cable, and it's a bit of a tight fit. So what I do is just bend it again like that. And then from here I can push it in like that, and then just feed it through a gap anywhere we've got. So I'm going to feed it through like so, and that's going to be connected to the ultrasonic sensor afterwards. Pull it nice and tight so it's out of the way. Like that. And we've got two other cables here, so I'm just going to connect these 4s on. Again, just bend it backwards a little bit. Like so. Feed that through. Pull it through the other side, like so. And then do the same on this side as well. feed that through. Okay, so we've got all those wires coming out. We'll deal with all these connectors after. And I think that's everything that we need connecting on that side. So the next thing we're left to do is just to put the base on, and using these screws match them up with the copper coloured spacers. And just go all around, making sure that nothing's trapped and everything fits okay. So the robot's nearly finished here. So we've got the lower part of the base on the upper part of the base. And all we need to do now is connect the sensors. So there's quite a few sensors on this part of the robot, whether you call this the back or the front. It doesn't really matter to the robot, but it's the side that's opposite to the caster. So I'll just go through what these sensors are and how to connect them. So what we've got is sensors here and here, and these are infrared LEDs, so it'll transmit an LED, an infrared light source, and then this will be a receiver. So if there's an object nearby, light will bounce from one LED off the object and into the other one. So they're not facing each other, so they won't directly get information to each other. It'll have to bounce off something. So that's how it'll work as a proximity detector. So we've got two of those, and they are held on by some of these copper spacers as well. I chose a medium height one for that, so I've got them both on the same side. So wiring them up, there is a cable that plugs in here. It'll only go one way around, so don't worry about getting it the wrong way around. And it's got the 4 pins, and that's on both of them, obviously. And then what those pins do is they go underneath, and they go into the part underneath here, and it's the only one with a 4-pin socket. So whichever one it fits into, it's the one that's closest to the back. It'll fit in like that, and you do exactly the same with the other sensor on the other side as well. So there you've got your sensors. You don't have to angle them like this. These can be moved to wherever you think that they should move to. I'll just put them like that for now. Okay, and then we've got the encoder sensors. So you might have noticed that on the back of the wheels there is a slotted disc that you can just see there. So as the wheel turns, that disc turns. And the encoder sensor, well, that'll work as an encoder. So basically, light will shine through those slots, and as it turns, the light will be blocked and then shine through, blocked and shine through. And it'll give the controller an idea of how far the wheel has moved and also the speed that the wheel is rotating. So you can do a bit of feedback control on that. And the sensor for that slots down from this side, down there, and there's one on this side as well. And there are 3 wires that connect to that. There, again, it'll only go one way around, so those wires go through, and what I did was I put them again through the slot here, and then to the only side bit that they would fit on, which is here. So it's behind the infrared distance sensors, so it's back there, and of course the same on the other side. We've also got a ultrasonic sensor. So this works a bit like a bat works. So it emits a ultrasonic sound. The T is the transmitter, so it will emit an ultrasonic sound. That will bounce off an object, and that sound will then reflect back into here, which is the receiver, the microphone. And there's a little circuit in here, and there's an algorithm. It knows the speed of sound in air, so it can calculate how long it takes. It knows how long it took for the echo of the sound to get back, and it can calculate the distance to the object. These are remarkably accurate, and they can work over quite a long distance, perhaps 1 or 2 meters. And it doesn't have to be a nice flat surface to reflect off. It's quite amazing the things that it will actually reflect off, things like clothes and your hand, etc. So we've got this ultrasonic sensor, and that is connected to a sensor board, which is here. So this sensor board, I had to build this up, and
the ultrasonic sensor is going to plug into here. And you'll notice that on one side it says GND, which is for ground, a few other bits. So you make sure that the sensor also has GND, ground. So you make sure that ground goes to ground on this one. So they do match up like so. Okay, so that's connected. And there's also a plastic bit here. So this plastic bit I got from the servo motor. So there's a servo motor that it comes with, a small RC servo motor from radar controlled aeroplanes originally, and it came with these a few of these plastic things. And I found the best way of connecting this plastic thing, there's a bit of a trick to this really. Make sure that the plastic is on this side, and then you screw through, and then it will screw through to the other side. Now the screws will come through. We don't want those screws to go too far, and there's a reason for that, because this motor is going to be mounted onto this plastic thing, and then there's a couple of the copper spacers here at the front that way, so it's mounted that way. And then we put this thing, this bit, onto the plastic of the servo motor, like that. And something you have to be very mindful of is that the screws don't catch on the motor body as it turns round. Very carefully, you can actually twist this manually just to get a feel for how it will turn around, so the robot can look around. Now the centre point of this servo motor, it's hard to define, so what you can do is just move it to one extreme, which is, it moves roughly, looks like it moves about 90 degrees, this servo motor. So wherever you can take this off and replace it until it looks like it's got about an even move on both sides, so that's roughly even that way. But when we've got power to this, you can tell the servo motor to go to this 0 position and then just recheck it. There's a small screw which will go down the shaft there, which will attach it to the motor. The ultrasonic sensor has got the 4 wires, and those 4 wires go through the body into the other side, and they go right at the back. You can just see there. So it might be wise to connect these. I might have had to take this bit off, but you might have to remove this bit just to make sure that these cables connect properly. Oh, and there's also the servo motor. There is a wire for the servo motor, and there are there's 2 lots of 3 plugs here. I think it goes on the one on the right hand side. And the way round it goes is there's a label that it says ground on one of these. You can't really see it very well there, but it says ground, and then that will be the brown wire for ground, then the red one, and then the orange one is the furthest one away, and that's the connections for your servo motor, like that. Okay, and then the last thing to do is put the batteries in. So the batteries, they were a new one to me. Well, they're these ones. So I got these on eBay, the 18650. Got them with a charger and 4 of these batteries for £10 actually. Now the way to connect them in, don't be fooled by the plastic battery case, because on the plastic battery case there are actually minus and plus signs here. Completely ignore those, because they're wrong for this robot. The ones to follow are the ones that are on the printed circuit board. So we've got minus here, plus and minus. Just get my ultrasonic sensor out of the way. Okay, so the minus of the battery is the flat one, so it connects like that. They are quite tight, and the way I find to connect these batteries is to put the flat side in. You might want to pull it out a little bit, gives it a little bit more space, and then push it in against the tab there. Also, I wouldn't push it against the wheel, because the axle of the wheel will be taking the pressure, so I put my hand behind and just put them in that way. It just protects the axle, because they're not very strong, these axles. You don't want to stand on this, it's not like a roller skate. Okay, and this one goes in the other way around, remember, so the nib here is the plus. So put the flat side of the battery in there, and then push against it. Whoops, just like so. And there you go. In my enthusiasm to put the battery in, the wheel came off. So we'll fix the wheel on. There we go. Okay, so the next bit we'll do is write a very basic program just to test out the robot, the simple bit, and then I'll show you how to install. Here's a whole library for this robot, so I'll show you how to do that. So we built up the robot and we put the batteries in, and you can switch it on. If you switch it on, it's the little switch here, and you should get some lights, should get something happening. So you should see that there are lights going on. Oh, actually, I can see that the sensor is working straight away. So the distance sensor is working. That one's not. So that's maybe picking up on something. And I haven't done this yet, but there's a little adjusting screw. So I presume you can turn that and change the sensitivity of this distance sensor. But I'll have to have a look at that because it seems to be... I think the green light means it's sensed something, and the red light just means that it's got power. So I'll have to have a fiddle with that in a little while. What I'm going to show you now is how to program this. And the first program we're going to write is just to get one of the wheels moving. And it's only a very, very simple program. It doesn't require you to install anything, any particular software except for the Arduino software. Okay, so let's go ahead and have a look at this. So I'll have a link to the program on my YouTube, but we can see the program here. So I've downloaded the Arduino programming environment from the Arduino website, and basically if you've not done Arduino programming before, it's worth going through how these things work. But there's two functions, setup and loop. Setup sets up your pins. That means the motor driving pins and the sensor pins, etc. And the loop is your main program. And what I've got above here is just a couple of settings. So these are variable names, and then these are the pins that they're attached to. So the left motor speed pin is connected to pin 5, and the forward pin is A0 and the backward pin is A1. That's on this particular Arduino Uno that we're using, and something similar with the right motor, but we're only interested in making the left motor move to start off with. So in the setup, I make all of the pins outputs because we drive an output from a microcontroller to make the motor move. And what I'm going to do is digital write left motor forward high and left motor backward low. So if one is high and the other one is low, then it will go forwards. And if that's vice versa, so if the top one is low and the bottom one is high, then the motor will reverse and go in backwards. And the third pin is the speed pin. So this one we analog write to it. And analog write any number between 0 and 255. So 255 is maximum speed, 0 is stationary. I'm going to change that to, let's say, 180, so medium speed. So let's connect it up and program it. The robot comes with, I'll just switch it off for now. It comes with a programming cable, and that just goes into the Arduino underneath there, like so. So I'm just going to plug that in, like that, all the way in. And then the other side goes into the USB port of your computer. And you should get a nice message from your computer. Now I'm going to put this robot onto, when you're programming robotics, often the motors can burst into life. So it's worth investing in a very expensive robot, something to hold them, a proper robot holding device. So I invested in this teacup. So put it on a teacup there. There we go. So we know that it's not going to go anywhere. Okay, so it's all connected up. And to connect the Arduino programming environment, you have to do two things. You only have to do these once, though, if you've never programmed your robot on this computer before. Under Tools, you have to tell it which port it's connected to. and you have to say it's going to be one of the COM ports, one of the higher numbers usually. So this one is COM46. It's not a serial port, it's a COM port. So connect it to that. So then it's connected through the USB, so the computer knows where to send the data. The next thing you have to do is tell it that it's an Arduino Uno. Now you can see here board Arduino Uno, Genuino Uno, it's already set. But if you go down and it's not set, maybe it's set somewhere else, well, that would be the wrong type of board. So you have to make sure that it is connected like that. So it has to be the Uno. So that's the two things you have to do. Then you have to write in this program. I'll put a link on YouTube, and then to program it, you go to this button here. So you click that, upload, it'll compile it. So it says compiling, and then there'll be a bar on the right hand side that says uploading. So green bar, when it goes all the way across, then it's uploaded. If it's the first time that the robot's connected, it might take some time. If all is okay, then it says done uploading, etc. If there's a problem, then it will tell you. Now, the motor has actually started turning, even though it's not got power, and that's because, not very good, but it's being powered through the USB port. So what I'm going to do is just turn it on to the motor, and there we go. So we've got power in that way. And we can tell that we could unplug that. So it's unplugged and it is connected. So I'll switch it off, stops, switch it on, and then it will burst into life. So it's going at a speed relative to, well, it was 180. If we set it to 255, it would go even faster. This is just the left motor. We can see that distance sensor is working now. You might want to make the right motor turn. You might want to make it turn, and then when the ultrasonic sensor detects an object, it might want to stop, turn round. Now, once we've made the first bit, once we've done the first programming, then it's up to your creativity. There you go.